Hello, good morning. Welcome everyone to our today's webinar, Roaming with AI on Reyee Wi-Fi system. My name is Vladimir Ortega. I'm a pre-post sales engineer for EPCOM. We are going to treat this subject today. So I'm seeing here that we have some attendees. If you can hear me well, you can please raise your hand in order to confirm. Thanks. Okay, we are receiving confirmation that everybody can listen, can hear me well. So let's give them like let's say a couple of minutes to wait for somebody else to join. Okay, I think that we can start now. So I'm going to ask you to download our Regi app on the Google Play and App Store, even in the App Gallery in Huawei. So please download this application. It's going to let you access a demo project that we have there. So you can test all the features and functionality. You need to register an account, confirm the account, and your inbox email. That is something that you can do later. It's going to work for the session, but you still need to register it later because if you don't do it after 3 days, it's going to be inactivated. So yes, please register and scan this QR code. I will give you like a demonstration in here. So this application is going to be really cool because it's a tool that will allow us, like I mentioned before, to access to a virtual project, and you can explore all the cloud features that we have in here that are really cool for you to test. So as soon as you register your application, your account on there, please scan this QR code. I will put it at the end of this presentation as well, so you can access to all these the mentioned features. So I will give you like a couple of minutes to do this. So and now we can start, and then we can start. Okay, let's begin with our today's subject, and we're going to talk about the Wi-Fi roaming, right? What is the Wi-Fi roaming? Basically, it allows a device to seamlessly connect to a Wi-Fi network while moving between different access points without losing its original IP address or the connectivity. This is a concept that is based or is being used since a long time. It came originally from the, let's say, the roaming between the use on the cellular and phone connections. So in the past, when all the mobile telecommunication started, it was necessary to not lose the phone call if you were traversing a street or if you were crossing or just routing from one city to another. So or from the point A to point B or to point C. So the roaming was invented in those days, and that, let's say, that concept was moved or was integrated into the Wi-Fi technologies nowadays. So basically, like I said before, it allows us to us to continue communicating with a mobile device, even if you are walking from one street to another, or if you're working inside a big mall, let's say, that have like several floors, you're not going to lose the connectivity. It's widely used these days because let's say that you're using like a, or you are making like a WhatsApp phone call or a video call. You're not going to lose connectivity. The service is going to continue being delivered to you. So basically, this is useful in environments with multiple access points, such as large buildings or expensive areas. Ensure continuous and stable connection due to movement. And the process is carried out seamlessly for the user. The user doesn't need to activate or enable something on their end devices in order to access to this service, and relies on interoperability standards such as IEEE, A02.11k, A02.11r, and A02.11b. As you are seeing here, we have two access points. This is an standard service set. They are connected to the internet or providing internet service. And we see here that we have a station that is moving from one access point to another access point. Basically, what it happens in the background, talking about the Wi-Fi roaming process, there are several steps that are going to occur, right? Um, the first one is the access point detection. The device scans signals from nearby access point. The second step is going to be the roaming decision that is based on signal quality. The device decides whether to switch to an access point. The third step is going to be the association with the new access point. The device associates with the selected new access point, authenticating and establishing a new connection. The fourth step is going to be like a smooth connection transition that is going to be a seamlessly transition is solved to avoid data loss. Uh, the next step is going to be the MAC address table update. The access point and the device update their MAC address table to reflect the new association. The sixth step is going to be the network parameter reconfiguration if it is necessary in some cases. So there may be some adjustments in the network settings, such as assigning a new IP address, but roaming can be used keeping the same IP address. This depends on the network design and the network configuration. Uh, mm, Next step is going to be the roaming notification. This only happens in managed environments. So let's say in centrally managed networks, roaming notifications are sent to a wireless network controllers, or all the access points that are located inside a cluster or so on can be notified that a roaming has occurred. The last step is going to be the connection optimization. So the device seeks to optimize its connection to new access point for efficient data transmission. So as you can see it here, we have, let's say, a warehouse. There are some pallets. There are some, let's say, products that are going to carry out there. And they are moving from, let's say, from the point A to the point B. There is a machine here just organizing the products as well. And there is a backbone deployed connecting two access points in two different areas. So as you can see here, there is a supervisor with his tablet, and he's using his tablet to let's say to check if the leftovers are carrying the products, if the pallets are being moved to one point to another. But if he traverses from this area to the second area, and as you can see here, the Wi-Fi, let's say coverage is being delimited by ring 1 and ring 2, he's not going to lose any kind of connectivity. So basically, this is the Wi-Fi roaming process. This is the traditional Wi-Fi roaming process. Moving on to the new technologies, we encountered the AI roaming based on artificial intelligence. This is something provided by Reyee. It was really, really well. And basically what it happens in the background is that it's going to implement some kind of machine learning algorithms in order to learn from some patterns on the time. And this is going to be really useful because it's going to create customized patterns based on vendors, based on devices. It's not the same to roam with a mobile device, with a phone, than been roaming or roaming with a, let's say, with a tablet or a laptop. Talking about the technical specification of the radios and antennas that each device has, they are different. So maybe some device is going to run at a certain, let's say, signal level compared to a tablet or a laptop. So basically, what AI roaming does is to learn from these pattern behaviors and just customize it depending on the device. So what is, or let's say the AI roaming, where is it applied? Okay, it is applied, let's say, for in a scenario one that we have here, office corridor corner. One of the major scenarios where AI roaming can play a significant role is the office corridor corner. This is something really common in buildings, right? When a station pass through the corner, the sudden appearance of a wall, let's say this one, between stations, they are original connected to an AP, maybe this will lead or result in a sudden RSSA drop. RSSA is a KPI managed on the Wi-Fi technologies, and this is signal strength indicator. This can last for a period and make the general roaming experience terrible. After turning on the AI roaming, AI will learn from the past roaming behaviors with sudden RSSI drops in this specific corner, okay? And it will optimize the strategy to guide stations to roaming here. So based on its learning experience, when new devices pass through the corner, AI will predict the roaming path of these new devices and potential RSSI drops that can happen in that time, in that moment, and let the new access point guide the stations to roam in advance before it getting into the, let's say, into this AL. As a result, the period with RSSI drops on this new station will be shortened. Maybe we cannot remove it from the equation, right? But it will be shortened. So all the overall roaming experience will be improved for the user. Talking about now the second scenario or case scenario, as an example, we have the factory container officer. So if you are seeing here, this is a huge warehouse. Maybe they have deployed there like a factory line, but you still need some kind of office in there, right? Some kind of office room where they can run all the operation, supervisors, control, operations, maintenance, etc. So as you are seeing here on the factory, we can have several omnidirectional access point deployed there, but we have like a sectoral access point just deployed in that area, in that room, just to provide service to the people that are working inside these container offices that are really popular these days, right? So in factories, maybe like I mentioned before, there are many container offices. This is being made of metal, And since they are made of metal, they have the ability to reflect radio waves and thereby greatly weaken Wi-Fi signal strength. This is something really common. When workers enter into these offices and close the door, their station will experience like a sudden RSSI drop, like I mentioned before with the scenario one, right? Because of the isolation of the metal made containers. Once AI roaming is activated, AI will learn from the past roaming experience at this location. If there are new stations passing here, AI will automatically predict their potential path of entering the container and proactively let the AP inside the container, this one, to guide the station to roam ahead of time, which could largely, in some cases, shorten, most of the cases, shorten or the station's roaming period with poor signal quality. So this is really interesting because traditional AI roaming is based just on KPIs, and these KPIs are going to be applied to each device. It's not something that is going to be customized by vendor, by kind of device, by brand, etc. So let's do a proof of concept because something that I want to show you that is going to be really interesting is the something that we have here with the augmented reality in order to check the roaming. So just give me a second, and then I will start a broadcast from my iPad. So just one second. Okay. As you can see here, let me try to maximize this one. Okay, I think that you can see it here. Okay, this is my Reyee app. Like I mentioned before, it comes with a demo project in here, so you can try all the features. You can test not just Reyee devices, even Reyee devices are going to be located here in a virtual form. So this is really nice. Once you register your application and scan the QR code, you can test all the features that I'm going to test here. So for this purpose, for today's purpose, I created like a project here. I have some physical devices. We just call it a backpack. It's a setup that is being made of two access point, one easy switch, tiny easy switch that provides PoE capabilities as well, and an easy gateway that is some kind of router that provides some security features as well. So basically, this is my setup. All of these devices are cloud managed, so that is something really cool from Reyee and Reyee this day. But we're going to focus today on the AI roaming. So as you can see in here, if we go back here to the toolkit, we can test the AI roaming test. So we can do it here. It's going to ask us, okay, do you want to do it in a traditional roaming test? The traditional roaming test is just to, let's say, manage or check all the devices, talking about the latency, the packet loss, but we are not going to do it in this way since we have augmented reality in the majority of the devices nowadays. We're going to take advantage of that functionality, right? So let's fire it up AI roaming test. This is going to ask us if all the access points are made by Reyee, and that is the case. I'm working remote and I'm here on a short and tiny space, and I will show you later what parameters or variables I change in this project, talking about or regarding the access point in order to perform this test of roaming, right? So I'm going to click in here, yes. You can upload a floor plan. We don't have it today, so we're going to test without a floor plan. So as you can see here, this is my backpack that I was showing you or mentioned to you today. I'm going to put some marking here because I have configured this RAP2260 G. So there is a cool model. It's a model it's a wall model, so you can install it in interiors. So let's mark here, and I will put here like a mark number 2, right? So just to determine that we have here a point or a landmark that is going to provide us with some kind of information. If you are seeing here on the screen, even with the augmented reality, is saying that I have minus 43 dBm. That is a good KPI, talking about radio signals. The latency is around 5 milliseconds, and the negotiated rate or speed is going to be something around 304 megabits. So as soon as I'm trying to get away from the router, you are going to see here that the dBms are reduced, right? So now it runs. I'm near to another access point, and as you can see here, we have another access point locator deployed inside my home, and all the devices, or let's say all the parameters just changed. It did the run. So it went from 62 dBm so to 0 dBm, to minus 40 dBm, sorry. The time consumed was 23 milliseconds, something really fast without any packet loss. I'm bit transmitting from this iPad, and the packet loss was something around 0. So I will set up another mark in here. I think that I call it the first one number 2, so I'm going to put here mark 1, and it's going to create another landmark for this. So as you are seeing here, it's drawing you some kind of a map. At the end, you can upload a floor plan, and it's going to work really well because it's going to draw the design in there. So as we get out and we do the road as well, if you're seeing here, this was the exact point location where the roaming occurred. So we are going back to the original setup, and the DVMs are changing, and suddenly or soon it's going to do the roaming. So it performed the roaming. As soon as the RSSI value change from or rise up to minus 77 dBm, that is something terrible, talking about the Wi-Fi signal. It did the roaming in this point to the another access point. So this is something really cool. I will end this, let's say, demonstration. So it's asking me if I wanted to see the report, right? So I will click it in here. It's going to generate a report. And as you can see here, there was two roaming count. The two roaming count was let's say up or increasing to 2. It provides me the average RSSI that was minus 51 dBm. That is something really cool. And it's a good parameter. The average latency was around 8 milliseconds, and the average negotiation rate, it was around 274 megabits. Something that is really interesting to see here is the packet loss. The packet loss rate was 0. The packet loss count was 0. The packet loss during roaming was 0. So if somebody is inside of a mall or something like that, the experience is not going to be affected, the user and experience, right? So this is something really cool. It gives you here like a cool graph talking about the behavior and RSSI and the latency as well. And something that you can enable in here is the Wi-Fi process, right? The AI roaming. So I'm going to show you here. It's located on advanced AI roaming. So it's learning about all this behavior and this pattern. So we need to have enabled this one that it says AO2.11k/B smart roaming. That's something that needs to be activated, and the AI roaming as well. We have like all these parameters deploy as well in the website. I'm going to show you here. Is showing me the IP ranking or the access point and the client ranking as well. It says that the station connected is my Apple iPad, and it has like a 100% of good signal. Okay. Okay. Let me close this screen. And I want to show you something really quick, talking here about the web user interface that is going to show us the same functionalities or more functionalities compared to the application. So if we go here into network-wide AI roaming, we're seeing here the same screen that I was showing you on my iPad, right? So it's saying that the roaming experience is good, the roaming RSSI in average is really good, and the roaming time as well. So it has the options that I mentioned before. They are enabling here. We can disable it as well. It is learning with their machine learning algorithms in the backend, and take a look that the numbers of AI profile are two. So they build two number profiles because I deployed this project yesterday, and I ran some tests in order for the algorithm to learn about the behaviors inside my home, right? So the RSSI before roaming, they are improving 10 dBms. So minus 60 dBm from minus 60 dBms is something that is really cool. It's going to improve our experience. We can also take a look on the roaming dashboard. So we're seeing here the clients, when the roaming occurred. It takes some time to reflect this information. The service level goal is about, or is around 100%. And you can also enable here layer 2 and layer 3 roaming. This is something that we're going to get in here just to explain it. Layer 2 roaming is when you do a roaming and you keep the same VLAN. So let's say that you have the same IP address and you move from one area to another area, but let's say the VLAN is going to be the same. Layer 2 roaming, and sorry, before going to layer 2 roaming is enabled by default. But if you were going to talk about layer 3 roaming, you can move you can move stations or roaming station from one access point to another access point located in a 4 area. And maybe there is going to be like a change talking about VLANs. Maybe you're going to be moved from VLAN 1 to VLAN 10. So in these cases, a tunnel is being built from the beginning in order to keep the let's say the traffic, because if you are moving from one VLAN to another VLAN, maybe it belongs to another subnet. So the IP address is going to change. So you can enable it in here as well. You can enable AI roaming for layer 3. That is something that is available in all the Reyee devices these days. Just resuming, is AI roaming is something that is going to help us and to improve the end user experience. So like I mentioned before, all the devices are compatible with this technology, and that's it, guys. Thank you very much for your assistance. I hope that you have learned something today, and just give me a second. I will put here. I will give like some minutes to answer some questions. So if the attendees today have some questions, just please put it on the question box there on the question chat, and I will answer you all the questions today. So I will give like a couple of minutes to answer a question if somebody is interested in or have any doubts at this time. Okay, I think that we don't have any questions for today. So I will let you here on this screen my email, my corporate email. So reach me if you have any troubles or doubt. I'm Vladimir Ortega. I'm a pre-post sales engineer from EPCOR. I belong to the engineering department. We have like a huge department with qualified people that are going to be glad to help you and to resolve all your doubts and inquiries and issues if you have it, right? So please contact us through my email. We can always help you with your projects, your design. We are like a company that provide like a customized and tailored service and attention to a customer. So I'm really glad to have shared this time with you guys. Hope that all of you learn more about the AI roaming on the Wi-Fi technologies provided by our brand Reyee and Reyee. So thank you very much. It was a pleasure and have a good one. Thanks.